Well, hello everybody. Here's what you missed the other day. This is section 2-6 over what's called piecewise functions. What you'll need in front of you today, you'll of course need your class notes, and you will also need a straight edge. Your calculator or brain would also be good to have also. So hopefully you have that in front of you. What we did is we gave back tests, we answered any questions, and then we went from there. And then we started right here with just a simple inequality thing. I wanted to make sure that you know the difference between x greater than 2 and x greater than or equal to 2. When we graphed inequalities, let me get some ink here. When we graphed inequalities that day, let me go pointer options, pen. Okay. When we graphed inequalities in our last unit, you did a real good job of knowing that I would have an open dot on 2 and everything to the right. On this next one, you know that there'd be a closed dot on 2 and everything going to the right. Unfortunately, here's what a lot of people think. They think x greater than 2 is the exact same thing as x is greater than 3. Because here goes their thinking, you can't use 2, so the next number after 2 is a 3. That's really, really wrong. Think about this for just a second. If here's 2, and I tell you that you can't use it, and here's 3, and I tell you that you can use it, there's an infinite number of numbers in between 2 and 3. There's 2.1, there's 2.2, there's 2.3, and the list goes on. So if you see x greater than 2, you can't automatically jump up to 3 because there's a lot of numbers in between there. Remember that as we go here in a little bit. So if you will, look at your example 1. What these are called piecewise functions. What we mean by a piecewise function, guys, is you're going to see graphs that look like this. You're going to see one piece doing something, and you might see another piece going another way. You'll also have to watch today, you're going to see open dots and closed dots, just like on that other screen. All that means is you can include that number or not. So hang with me as I go through this. Overall, it's a pretty tough day for a video. So what I have right here, guys, I have two equations. I'm going to label this top equation a 1 and this bottom equation a 2. So if you would, do the same thing. Label that top equation 1, that bottom equation 2. Since I have two equations, I'm going to come over here and make two XY charts. Here's a chart for number 1. Here's a chart for number 2. So draw those real fast if you would. Now here comes the hard part. Look at this domain that we're given right here. It says x is less than -1. Here's how we're going to attack that. You always have to write down this number. So I'm going to write down a -1. Since it just says less than and it doesn't say less than or equal to, I'm going to put an open dot right next to it. That's my cue that there's an open dot on -1. Now I need you to pick some numbers less than -1. So we're going to pick -2 and -3. Now to get your corresponding y values, plug these numbers right here back into equation number 1. So I'm going to go -1 minus 2, and I'm going to get -3. I'm going to go -2 minus 2, and I'm going to get -4. I'm going to go -3 minus 2, and I'm going to get -5. So what I'm going to do now is I'm going to go graph piece number 1. So I'm going to go plot the point, -1, -3, and then right here, guys, we said it should have an open dot, so I'm going to put an open dot right there. I'm going to plot the point -2, 4, and 3, -5. And then I'm going to graph this thing. So here's what you just did. You graphed the ray, not the line, but the ray for all the values x less than -1. You only get to use -1 to the left. So you don't get to use any of that. Now let's go pick on branch number 2. It says x is greater than or equal to -1. So you got to write down a -1. And then it says greater than or equal to, so I'm going to color in a dot right there. Now you need to pick some numbers greater than -1. So I'm going to pick 0, and I'm going to pick 1. Just some numbers greater. You can pick whatever you want. We're going to plug these numbers into the second equation there. So I'm going to go -1 plus 3, and I'm going to get 2. I'm going to go 0 plus 3 and get 3. I'm going to go 1 plus 3 and get 4. Now let's graph those. So I'm going to go -1 up to 2. And notice that you got a closed dot by it. So I'm going to put a closed dot on it. I'm going to plot the point 0, 3 over 0 up 3 and 1, 4. And then I'm going to graph those points. Hey, I want to point out a couple of things real fast. This is your equation number 1. Notice that the inequality is pointing to the left. This is going to the left. This inequality is pointing to the right. It's going to the right. So that's the graph of it. Now here comes kind of the hard part. We're going to figure out the domain. The domain says, what x values are we using? Here's what we mean by that. If I draw a vertical line, over here at 10, -10, if I draw that down, will I hit this line at some point? And the answer is yes. I would also for -11, -9, -8, -7. Then I ask myself, hey, would I hit it at -1? If I let x be -1, draw a vertical line, are you hitting one of your graphs? And you are. And then 0, 1, 2. My domain is going to be any number that I want to work with. So my domain is -infinity to infinity. If you look back up here, we're using every number. We got all the numbers less than -1 and all the greater numbers greater than -1. So we got them all. Now here comes the hard part, the range. The range says, what y values are you using? So if I extended this y-axis, if I drew a horizontal line right here at -20, would this graph hit this line sometime? And the answer is yes. If I did it way down here at -50, would it hit it someday? And the answer is yes. And I didn't want to do that. Let me see if I can shrink that back down real fast. So now I'm going to ask myself, as I go up, what y values am I using? I'm going to use all the y values all the way up to this point right there. So I'm going to use them all the way up to -3. And then I'm going to jump. I'm going to jump all the way up to a y value of 2. Well, here's how I write that for my range. I'm going to say, hey, I'm going to use all the numbers from -infinity to -3 along with, so or union. Hey, notice though I put a parenthesis on -3 because it's an open dot. Notice I'm using a 2, so I'm going to go bracket 2 to infinity, because this line starts at 2 and goes up forever. The next little piece is just want to make sure you can pick out where to plug it. To find f of 0, you have to decide which equation to put it into. So here's what you got to do. Think of 0. Is 0 less than -1, or is it greater than or equal to -1? So you got to decide to plug it in equation 1 or 2. Since 0 is greater than -1, I'm going to plug it in right here. So I'm going to go 0 plus 3, and I'm going to get 3. Let's pick on negative 5. You're going to ask yourself, is negative 5 less than negative 1 or greater than negative 1? Well, it's less than negative 1. So I'm going to go negative 5 minus 2, and I'm going to get negative 7. Let's try 1. Does it go into x is less than negative 1 or x greater than negative 1? Goes right there. So I'm going to go 1 plus 3 is 4. And then 4. 4 is definitely greater than negative 1. So 4 plus 3 is 7. Hey, also you could look at your graph. 4, looking up at your graph, it's going to hit about 7. So it's working out pretty good for us. Okay. Roll on to number 2. If I got you a little lost on there, keep hanging with me. It gets easier. I got 1/2 x plus 2. And I got negative 3 if x is less than 2. So let's come over. Let's call that equation 1, that equation 2. Now I'm going to set up my little xy charts again. So there's xy, xy. Here's my chart for equation 1, my chart for equation 2. So draw those real fast if you would. And then look at your domain. You have to write down this number no matter what. So I'm going to write down a negative 2. Now, I need some numbers greater than negative 2. So this is all up to you. Some numbers greater than negative 2 could be negative 1 and 0. And those would work. Those would work. But since I have a fraction and I don't like decimals, I'm going to pick multiples of my denominator. So I'm going to pick multiples of 2. So instead of picking negative 1, I'm going to go negative 2, 0, and 2. Would it be wrong if you use negative 2, negative 1, and 0? Nope. Just you're going to get a decimal. I'm not. So let's go plug these back into equation 1. 1/2 of negative 2 is negative 1 plus 2. So I'm going to get a 1. When I plug in a 0, 1/2 of 0 plus 2 is 2. When I plugged in a 2, 1/2 of 2 is 1 plus 2 is 3. Now let's go graph that. So I've got negative 2, 1. And remember, this is an open dot because it's just greater than. So I got negative 2, 1. I've got 0, 2, and 2, 3. Connect those dots, and there's what your first piece should look like. That's what your first piece will look like. Now let's go graph your other piece. It says for x less than or equal to negative 2. So you got to write down the negative 2. No choice. And some numbers less than negative 2, I'm going to use negative 3 and negative 4. Now this one's kind of easy. There's no x value here. So all of your y answers are going to be negative 3. So when I go to graph that, I'm going to go negative 2, negative 3, and then I got to decide if it's an open dot or a closed dot. When I look less than or equal to, looks like it's going to be a closed dot. So I'm going to have negative 2, negative 3, negative 3, negative 3, and negative 4, negative 3. So there's what that line looks like. The domain and the range, there's two pieces. Now in this one you're just using negative 3 over and over and over. So to write that correctly for the range, I'm going to say I'm using negative 3, or come over here, what's the littlest y value that you're using? The littlest y value that you're using is a 1, but you're not using a 1. So I'm going to put a parenthesis 1 to infinity. I skipped over the domain because that's negative infinity to infinity again. Now the f of 0, negative 5, 1, and 4, we just got to decide where to plug that in at. So f of 0, you got to decide the 0, is it greater than negative 2 or less than negative 2? Well, it's definitely greater than negative 2. So I'm going to go in my brain or my calculator, 1/2 times 0 plus 2, and I'm going to get 2. Plug negative 5. You got to ask yourself, is negative 5 greater than negative 2 or less than negative 2? It's less than. So your answer is negative 3. F of 1. Got to ask yourself, is 1 greater than negative 2 or less than negative 2? I'm hoping really fast you said it's greater. So I'm going to go 1/2 times 1, which is 1/2, plus 2. So this answer becomes 2.5. And then when I pick on 4, 1/2 of 4 is 2. 2 plus 2 is 4. So there those are. That's how the lesson's going to go so far. I'm going to do number 3 with you. I'm going to skip number 4, and then I'll show you number 5 and number 6. So head on over to number 3. I've got x plus 2 if x is less than 4, and I got the opposite of x divided by 2 if x is greater than negative 4. Hey, since these numbers are the same, I know my domain before I even start, negative infinity to infinity. Hey, now let's come over and draw your xy chart. Here's equation 1, equation 2. So I'm going to put a 1 and a 2 right there just to try to help you out. Now let's pick on equation 1. I've got x plus 2 if x is less than negative 4. Remember, you got to write down that number. You got to use it, negative 4. Now, give me some numbers less than negative 4. And some numbers less than negative 4 could be negative 5 and negative 6. So now let's plug those in. Negative 4 plus 2 is negative 2. Negative 5 plus 2 is negative 3. Negative 6 plus 2 is negative 4. Let's plot those things real fast. Hey, let's clean this up too real fast. Since this just says less than negative 4, open dot. So I've got negative 4, negative 2, open dot. Negative 5, negative 3, close dot. Negative 6, negative 4, close dot. Connect those. Put an arrow at the end, of course, to show the world that it goes on forever. Hey, peek back up here. Look at equation 1. The inequality is pointing to the left. This line goes to the left. So that's a good check. Now let's pick on equation number 2. You have to use negative 4. And it's going to be a closed dot. I spy a denominator over 2, so I'm going to pick multiples of 2. Because if I do that, guys, I know I won't have any fractions. So I need some numbers greater than negative 4. So I'm going to pick negative 2 and 0. Would it be wrong if you picked negative 3 and negative 2? It wouldn't be. You're just going to get decimals. And I don't like to work with decimals. So let's plug these in down here. I'm going to get negative 4 divided by 2. So I'm going to get 2. Negative 2 divided by 2, I'm going to get 1. And 0 divided by 2, I'm going to get 0. Let's go plot it. I've got negative 4, 2 with a closed dot. I've got negative 2, 1 with the dot. And I've got 0, 0. So here's what this one's going to look like. I missed my dots by just a little bit, but that's okay. Hey, now the range, I'll redraw it real fast. The range asked, what y values are you using? So picture this. This one's a tricky one. This one uses all the numbers from negative infinity all the way up to negative 2. Look what this one does. it uses all the numbers from 2 below. So it goes from negative infinity to 2. Think about this. I don't use any y values up here, it looks like. So I start using a y value of 2, and then I use everything underneath it. So my range is going to be negative infinity to 2. I'm going to put a bracket on the 2 because of that closed dot. You can say, but Mr. Harris, we didn't talk about this one. True, because this line covers this line. When I find f of 0, 0 is greater than negative 4, so 0 divided by 2 is 0. When I plug in negative 5 is less than negative 4, so I'm going to use this one. Negative 5 plus 2 is negative 3. When I pick on 1, 1 is greater than negative 4, so I get negative 1 half. And when I pick on 4, this one doesn't include, this is less than negative 4, greater than negative 4. So negative 4 divided by 2 is negative 2. So there's the piecewise graph so far. There's the piecewise graph so far. I've noticed I've been 21 minutes already. Hang with me. I got about 4 to 5 more minutes, and then we'll have this lesson whipped. So like I said, guys, I'm going to bypass number 4 real fast. What I'll do for you is I'll list your XY charts just super fast if you wanted to pause the video and see if you would have gotten it right. But I'll list my answers real fast. And like I said, if you wanted to pause the video and see if you could have done this one on your own, feel free to do that. So there's what your XY chart should have looked like. Your graph would have looked something like this. I would have had 2, 3, 3, 3, and 4, 3. So I would have had this. And I would have had 2, negative 1 with an open dot, 1, 1, and 0, 3. So if you wanted to make sure that you knew what you're doing, you could have paused before and then matched them up. But go back to your number 5 now, or go to your number 5. What we're trying to do on number 5 here is do what 1, 2, 3, and 4 look like. I'm going to try to come up with the equation that goes here, and then the word if, and then the domain, and then the equation that goes here, the word if, and the equation that goes there, the domain. So I'm going to pick on this one first. I'm going to pick on him first, this one second. Notice that in this case, all of my y values happen to be 1. 1, 1, 1, 1, 1. So since that's a horizontal line, it has an equation of 1. If you wanted to think about it a little different, it has a slope of 0 because it's not going up any. So it's 0x plus, and it's crossing the y-axis at 1. But 0 times x plus 1 is 1. Hey, now here comes kind of the hard part. I got to decide what x value I'm using. Well, when I look at this, here's x is 1, 2, 3, 4. Come down with the vertical line. What x value do I hit? I hit 1. It's got a closed dot on it, and it's going to the left. So I'm going to say my y values are 1 if x is less than or equal to 1. So I've got that one out of the way. Look at problem number 2 now. And what we did in class, just to make it easier, we redrew this so it had a slope of exactly 1. So draw that if you would, guys, and then ignore that one for just a second. The only reason I did that, it makes the problem a lot easier. So, and I can kind of hide that one to where it won't even be there. I can color it in white a little bit. But here's what I'd like to do. Look at that new line that I drew. I need to figure out the slope of it. Well, the slope looks like I'm going to go up 1 over 1, up 1 over 1. So far I have 1x. That's my slope. Now we have to figure out where would it cross the y-axis if I continued that slope. So instead of going up 1 and over 1, let's go down 1 and over 1. So look right there. That's the b value that I would hit. And it happens to have a value of 2. So the equation of this line, even though it starts here, is x plus 2. But you can come back and say, but Mr. Harris, it doesn't hit the y-axis. And you're right. So that's where we tell it here. Look at this point right here. Look down here at what x value I'm using. I'm using an x value of 1. It's got an open dot, so I'm going to say if x is greater than 1. So there's my answer. So it's kind of going backwards. Then I got one more coming your way. This one's a little tougher. There's 3 pieces. Here's graph number 1, 2, and 3. So let's pick on the first one first. I'm going to have some equation and then the word if. See if you could figure out the slope on number 6. It looks like I'm going to go up 2 and over 1. Up 2, left 1. So that slope is negative 2x. And then ask yourself, where does that thing hit the y-axis? Well, it looks like it hits at 1, 2, 3. So the equation of that, negative 2x plus 3. Now you have to tell the world what x values you're using. So I got if. Ignore these 2 guys right here. Come straight down. What's your x value right here? It's 1. So I'm going to say this line works only if x is less than 1. And I put only less than because it had an open dot to it. Let's pick on this guy right here. It's always 1, 2, 3. It always has a value of 3. So I'm going to say f of x is 3 if, and then we have to tell what x values this works for. Trace straight down, and I get an x value of 2. So I'm going to say my answer is going to be 3 as long as x is greater than 2. Now the next piece is a little weird. We're not going to do that to you very much, but just to practice writing the equation, this slope is down 1 over 1. So the slope is negative 1x. See if we could use that slope, though, to see where it would cross the y-axis. So instead of going down 1 over 1, let's go up 1 over 1. Hey, what's that b value right there? It is 2. So there's the equation. To bring it home, I got to tell what x values it's used for. Well, it's only used between 2 and 3. So to write that, I'm going to say 2 less than or equal to x less than or equal to 3. That takes us back to that first chapter that we did. But there's the lesson. Hey, it's a tough little lesson. It is the toughest lesson that we're going to do out of this second part. So good luck with it. Give it a good try and buzz in if you have any questions. Good luck.